Welcome to Lecture 7 of UX203. We have built the structure, the visual hierarchy, and the visual language of the interface. Now we breathe life into it. Through interaction design and micro-interactions. Interaction design is concerned with how an interface responds to user input. Micro-interactions are the specific, small-scale moments within that response. The button state that changes on hover, the checkmark animation that confirms a save, the loading bar that tells you your upload is in progress. These moments are invisible when done well, and infuriating when done poorly. We are in Lecture 7. Everything we have built to this point, research, structure, hierarchy, typography, color, is static. Interaction design is where the interface becomes dynamic. Lecture 8 will address the accessibility dimension of these interactions. Today we focus on the design principles and patterns that make them work. The evidence for investing in interaction design is compelling, and it comes from three different angles. 90% of users cite interaction quality as a determining factor in whether they trust a product. Not visual design. Not copy. Interactions. The moment a button does not respond, a form does not validate, or a loading state does not appear, trust erodes. Optimized micro-interactions, progress indicators, skeleton screens, animated transitions, make interfaces feel up to 4 times faster than their actual load time. Perceived performance is often more important than real performance. An interface that feels instant is preferred over one that is technically faster but feels sluggish. 38% of users stop engaging with a product if the content or layout is unattractive, which includes unresponsive interactions. An interface that does not respond to touch or click is perceived as broken, not just slow. The most important conceptual distinction in interaction design is between affordances and signifiers. Two ideas often confused, with expensive consequences. An affordance is a property of an object that enables an action. A physical button has the affordance of being traceable. Its three-dimensional form suggests that it can be pushed down. In digital interfaces, affordances are functional properties. A link can be clicked. A text field can receive input. A handle can be dragged. Affordances are not visible by themselves. A flat touchscreen has the affordance of being touchable everywhere. But that does not tell the user where to touch. This is the problem that signifiers solve. A signifier is a visual or behavioral cue that communicates an affordance. The underline on a link is a signifier. The raised appearance of a button is a signifier. A cursor change from pointer to hand is a signifier. Signifiers make affordances discoverable. The most common interaction design failure is providing an affordance without a signifier. A clickable area that looks like static text, a draggable element with no drag handle, a scrollable container with no scroll bar. Users do not discover affordances that have no signifiers. They assume the functionality does not exist. Slack's interaction design is distinctive because of how many interactive states it maintains simultaneously: message hover actions, emoji reactions, thread counters, read receipts, status indicators, typing indicators, without the interface feeling cluttered. The solution is progressive disclosure. Signifiers appear only on hover or in response to context, so that the interface rests in a clean state and reveals affordances only when they are relevant. The message hover actions in Slack, emoji, reply, more options, appear only when a message is hovered. At rest, they are absent. This is a deliberate signifier choice. The signifiers would clutter the reading experience if always visible, so they are revealed contextually. This is a high-level interaction design decision, balancing discoverability against visual noise. Every interaction is a cycle between user action and system response. Designing that cycle correctly is the foundation of usable interaction design. The trigger is the user's initiating action: a click, a tap, a keystroke, a scroll event. Designing the trigger means deciding what input method is appropriate. Should this be a button click or a keyboard shortcut? Should this be triggered by hover or by explicit interaction? Rules define what happens when the trigger fires. Under what conditions is the action available? What validations run? What state changes occur? Rules should be visible to the user where possible. Grayed out buttons with tooltips explaining why they are disabled are better than buttons that simply do nothing. Feedback is the system's response to the trigger, the state change, the animation, the status message. Feedback closes the loop. Without it, Users are left wondering whether their action registered. Good feedback is immediate, specific, and proportional. A small confirmation for a small action, a more elaborate response for a significant operation. Some interactions change the system into a persistent mode, an edit mode, a selection mode, a drag mode. The interface must communicate that the mode is active and provide clear exit paths. Users who accidentally enter a mode without a clear exit become confused and frustrated. Loading states communicate that a process is running, and the system has not frozen. The spectrum runs from a simple spinner to a detailed progress bar with percentage to a skeleton screen that shows the shape of the content before it arrives. The choice depends on duration. Spinners for sub-second waits, progress bars for multi-second operations, skeleton screens for content-heavy loads. Success states confirm that an action completed correctly. The canonical example is the green checkmark on form submission. Success feedback should be unambiguous, immediate, and brief. Do not make the user stare at a success screen for 5 seconds before proceeding. Error states communicate that something went wrong and critically, what the user should do to fix it. Generic error messages, something went wrong, please try again, are one of the most common UX failures on the web. Specific, actionable error messages. Your password must be at least 8 characters and include a number. Dramatically reduce user abandonment. Empty states appear when a list, dashboard, or data view has no content. A new user's inbox, an empty search result, a cleared notification tray. Empty states are opportunities. A well-designed empty state explains what will appear here and provides a clear action to create that content. A blank page with no explanation is a user abandonment trigger. Gmail manages one of the highest interaction densities of any consumer web application, thousands of interactive elements per screen for power users, and does so without cognitive overwhelm. The key mechanism is consistent system-wide interaction patterns. Every action, archive, delete, snooze, label, uses the same hover to reveal signifier pattern. Users learn the pattern once and apply it everywhere. The undo send micro-interaction in Gmail is widely cited as a design classic. After sending a message, a toast notification appears with an undo action, available for a configurable number of seconds before the message is irreversibly sent. This micro-interaction addresses one of the most common anxiety-producing moments in email, the regret after hitting send. The solution is not a confirmation dialog before sending, which would add friction to every send, but a reversible action immediately after. Material Design 3's motion system codifies the principle that animation should communicate meaning, not just add visual interest. Every material motion decision has a functional justification. Elements that enter from the bottom are new. Elements that exit to the top are leaving. Shared element transitions communicate continuity between two related views. The motion tells the story of the interface's spatial model. On the left, a modal that appears instantly with no transition. The user's context model is disrupted, something appeared from nowhere. On the right, the same modal with a material container transform transition. It expands from the element the user clicked, establishing spatial continuity. The user understands where the modal came from, and by implication, where it will return when closed. Every micro-interaction has 4 components, and all 4 must be designed deliberately. The trigger defines when the micro-interaction starts. A user action or a system condition. User triggered. The user clicks a like button. System triggered. The battery drops below 10% and a warning appears. Design the trigger to fire at exactly the right moment, not too early, not too late. Rules define the behavior, what changes in what sequence under what conditions. If the like button is already liked, the trigger fires the unlike behavior. Rules must handle every edge case. What happens on error? What happens when the action is repeated? Feedback is the sensory output, visual, auditory, haptic, that communicates the result to the user. The color change on the like button, the satisfying pulse animation, the notification badge increment, all feedback. Feedback should be specific to the trigger and proportional to the significance of the action. If the micro-interaction has duration, a loading state, and animation, a countdown, it has a loop. Design the loop. How does it progress? Does it repeat? How does it end? If the interaction changes a persistent system state, it creates a mode. Design the mode. How does the user know they are in it? How do they exit? The moment your product asks the user to wait is a moment of risk. The user's attention may wander. Their trust may erode. Designing the waiting experience is as important as designing the loaded experience. Spinners are appropriate for sub-second waits where content is loading in place. They communicate. The system is working without implying anything about duration. Beyond 2 seconds, a spinner becomes an anxiety-producing signal of uncertain waiting. Skeleton screens, placeholder shapes where content will appear, dramatically improve perceived performance. They communicate not just loading but, this is what is coming. Users begin orienting to the layout before the content arrives. Research shows skeleton screens reduce perceived wait time by up to 20%, even when actual load time is identical. For long operations, file uploads, data exports, multi-step processes, a progress bar with percentage is superior to any indeterminate indicator. Users can estimate time remaining and make decisions about whether to wait. Indeterminate loading for a 2-minute operation is one of the most frustrating UX experiences. On the left, a form with no interaction feedback. The user fills in the email field incorrectly, submits, and receives a generic error at the top of the page. They scroll up, read the error, scroll back down, find the field, fix it. 3 unnecessary actions before recovering from the error. On the right, the same form with inline validation. As the user leaves the email field, the field validates immediately, before submission, and places an error message directly beneath the field. 0 unnecessary navigation. The feedback is immediate, specific, and co-located with the error. This is what makes the difference between a form users complete and one they abandon. Every interactive element must have a design for every state it can be in. Designing only the default state is designing half the interaction. The default state is how the element appears before user interaction. The resting state. This is what ships if no other states are designed. The hover state signals affordance on pointer devices. A color shift, a shadow, a cursor change, any one of these communicates. This is interactive, you can act here. Without a hover state, links and buttons in their default state are indistinguishable from static content. The focus state is the keyboard navigation equivalent of hover. It must be visible. WAG-AA requires a visible focus indicator for all interactive elements. Most browser default focus rings are stripped by CSS resets without a replacement, a common accessibility failure. The active state communicates that the action is in progress, the button is being pressed, the click has registered. This state is often omitted, leaving users unsure whether their click registered at all. Does every interactive element have explicit designs for default, hover, focus, active, disabled, loading, success, and error states? If a state is missing from the design file, it will be implemented inconsistently in code. Is there a loading state for every asynchronous operation? A button that triggers an API call should show a spinner or disable itself while the call is pending, preventing double submission and communicating that the action registered. Are all error messages specific and actionable? Replace an error occurred with the actual cause and the actual remedy. Every generic error message is a user abandonment risk. Does every list, dashboard, or data view have an empty state design, with an explanation and a call to action to populate it? Has at least one complete interaction been reviewed as an animated prototype, trigger through feedback to state change with a user watching and thinking aloud? Affordances require signifiers to be discoverable. An affordance that has no visible signifier is, for most users, functionally absent. Design the signifier as carefully as you design the affordance. Feedback closes the loop. Every user action that changes system state must have a corresponding feedback signal, or the user will be left uncertain whether the action occurred. Uncertainty erodes trust faster than any visual design problem. Skeleton screens reduce perceived wait time more effectively than spinners. For content-heavy loads, showing the shape of what is coming is both functionally useful and psychologically reassuring. 3 questions for this session. You are designing a form that requires a slow back-end validation. Checking whether an email address is already registered takes 2 seconds. How do you handle the interaction state during that 2 seconds without creating a frustrating experience? You have been asked to add hover states to every button, and link in an existing web application. The application is used equally on desktop and mobile, and hover does not exist on touchscreens. How do you approach the interaction design problem of signaling affordances without relying on hover? And think of a micro-interaction from an app you use every day, one that you find satisfying. What is the trigger, the rules, the feedback, and the loop? What makes it work? In Lecture 8, we complete the design foundations with accessibility and usability, the principles that ensure the interfaces we have built can actually be used by everyone. See you there.